Guys, and welcome to anyone who's new. This is a channel that gives detailed descriptions and step-by-step solutions on a variety of important topics. If you have not already, please hit the subscribe button to stay up to date with our videos and keep on learning something new. It really helps the channel make videos frequently and is completely free. Also, please comment down below if you have any questions or if you want me to cover a specific topic. Thanks, and let's begin with our next topic, classifying numbers. So first we have natural numbers. So natural numbers are basically our counting numbers that we use every day. So it's like 1, 2, 3, 4, etc., etc., etc. So as you can see here, I displayed all the counting numbers and it goes on and on. So as you can see, I also have the square root of 16 and 3 over 3. And you're probably wondering why. And that is because the square root of 16 is actually 4. So it is technically a natural number since you can count to 4. And also 3 over 3, if you simplify it, you get 1, and that is also a natural number. So as you can see here, these two technically work because they're equal to natural numbers, as you can see here. So the next one is whole numbers. So whole numbers are basically an addition to the natural numbers, and the addition is the 0 because that natural numbers does not have 0, but whole numbers do. And they also contain all the counting numbers too. Then we have integers, and integers are numbers that are negative and positive but also include 0. So as you can see here, I have -3, -2, -1, and it goes all the way back. I just gave a few examples of the negative numbers. So you can have like -1 million, whatever. But it also has the 0 and our counting numbers. So it's like a combination of the natural numbers, whole numbers, and now negative numbers. Then we have rational numbers. Rational numbers are numbers that can be expressed as fractions. So as you can see here, we have 7/9, and that is a fraction. But it also contains all the integers, whole numbers, and natural numbers. And if you're confused why I have this 0.33 repeating, you're like, why do we have this decimal? And you probably don't know that this is a fraction. This can be expressed as a fraction, and I can quickly show you why. So as you can see here, we can make this equal to x. So we can have x equals 0.33 repeating. So if we do 10 times x, so 10x, we get 3.33 repeating since a decimal point moves one right, because you multiply by 10. And then we can also say that x equals 0.33 repeating. So we have two equations, and all we have to do is subtract it. And we get 9x equals, now these cancel out because you're subtracting it, 9x equals 3, and then you can do x equals, and you divide by 9 on both sides, and you get x equals 3/9. And as you can see, this is a fraction. So that is why 0.33 repeating is an example of a fraction. And there are other continuous decimals that can be represented in fractions, but this is just one example. Finally, we have irrational numbers. So irrational numbers cannot be expressed in fractions because they go on and on and on. So as you can see here, if we have the square root of 2, if you put that in a calculator, you get a decimal that just goes on and on and on, and it cannot be expressed as a fraction. And also, as you can see here, we all know that pi is 3.14, and it keeps on going on. That's why we just call it 3.14. But 3 times pi is basically multiplying this humongous number times by 3, and it still cannot be expressed as a fraction. So that is why it is an irrational number. So everything that we've talked about, the natural numbers, the whole numbers, the integers, the rational numbers, they're all in a group. But there's also another group with the irrational numbers, since they don't contain the whole numbers, the natural numbers, etc., etc. But all of these numbers, every single one of these, are inside the real number box. Real numbers are anything on a number line. Like, you can write pi on a number line, even though it is an extremely long decimal. So that is why real numbers are natural, whole numbers, integers, rational numbers, and irrational numbers. So those are all classified as real numbers. As you can see, I've provided an example for each of these. And so that explains to you a whole section of all the numbers we use in math. Now, numbers that are not complex, that are complex numbers, are not real numbers. For instance, these deal with the imaginary numbers. So you probably have heard of I, which we use a lot in math, and we learn about it more in Algebra 1, but we will focus on a later video on the numbers related to I. But just so you know that these are not the same as real numbers. So as you can see here, 3i is still an imaginary number. So it is considered as complex. And if you don't know already, I is equal to the square root of -1. So this is technically equal to 2i, because it's the square root of -1 times the square root of 2, and you get 2i, because the I takes away the square root. So this is also complex, and as you can see, these are all classified in examples as complex numbers. So as you can see here, this is a table that shows all the numbers we've discussed in this video. We have the real numbers, which we discussed, that are the irrational numbers, the irrational numbers, the whole numbers, the natural numbers, and the integers. So that is all in this humongous box. And we can see the examples for each of them, as you can see here. And you can pause the video to examine more about this. But we also have to look at the outer box, and the outer box is not connected to the real numbers, since it is complex numbers and they're imaginary, and imaginary is unreal, so that makes sense. So this is all we have for today's video, and hopefully you learned something new or got a refresher on the different types of numbers. If this helped, please subscribe and like the video for more. Thank you, and have an amazing day.